So by now, we have learned the basic definition of the angles, and we have learned the two ways to measure the angle, right? So the first one is the degree measure. We just divide a circle into 360 equal arcs, and each arc is called the 1 degree. Then you just need to count the degrees of the intercept arc of the angle to get the degree measure of this angle. And this is the first way to measure an angle. And the second way is to begin with a unit circle, right? And then if we consider one angle, say angle alpha, and to find the reading measure of this angle, we just need to get the length of this intercept arc. Let me use a color. So this is the intercepted arc of this angle. Then let me call this S. So this S, the length of the intercept arc of this angle, is called the reading measure. Because this is a unit circle, so we know the radius R is equal to 1. So no dimensions, not the 1 inches or the 1 feet, right? So that means the reading measure of angle is just a real number. And this is a second way to measure an angle. We know the relationship between these two ways to measure angle. That is the 2 pi. And this is a reading measure of the full angle of a circle, which should be equal to 360 degrees. So that is the pi equal to 180 degrees. And we can use this identity to convert between the degree measure and the reading measure. Now, let's talk about the arc length. So right now, suppose we have angle, and we know the reading measure of this angle alpha. How can we find the corresponding length of this intercepted arc? So we know in a circle, the length of the intercept arc varies directly as the angle. So let me use S for the length of the intercept arc and the alpha for the reading measure of this angle. So that means S, this length of the intercept arc, should be equal to a constant of a variation times the reading measure of this angle. So we have a constant of variation K times alpha. So in such a way, we set up the relationship between the length of the intercepted arc and the corresponding angle. And now let's apply this to the full circle. Okay, so we know for the circle, the circumference is the 2 pi r, right? And then the full angle for the circle is the 2 pi. So let's just plug in 2 pi r for this S and 2 pi for the alpha. So we have the K times 2 pi, which is equal to 2 pi r. And we cancel the 2 pi from the both sides. Then we just get K. This constant of variation is equal to the radius of the circle, r. So now we can plug in this back into this formula. Then we get the formula of the length of the intercepted arc of an angle. So that is S is equal to R times alpha. Here this alpha is in reading measure. Okay, you must measure this alpha, angle alpha, in reading measures. So this is the formula for the length of the intercepted arc. Okay, so that is just equal to the radius of the circle times the reading measure of the angle. Now let's look at the one example on the page 430, problem 94. Okay, in this 94, we need to find the length of the arc intercepted by the given central angle alpha in a circle of the radius r. And we know the angle which is equal to 60 degrees, and the radius r is equal to 2 meters. So now let's try to find the length of the intercepted arc. So this is the page 430, problem 94. So angle alpha is equal to 60 degrees, and radius r is equal to 2 meters. So first, we need to convert this degree measure into a reading measure so that we can use this arc length formula. So alpha equal to 60 degrees, and then we just multiply this guy by pi over 180 degrees. Okay, so now you can cancel this 2 degrees so that you can get a real number, which is the reading measure of this angle. So then you have the pi over 3. Just keep this answer in the exact form. Okay, don't use the 3.14 to replace the pi. So keep the pi. And then now we can use this arc length formula. So the arc length S is equal to R times alpha. So R is equal to 2 meters. And then alpha is equal to pi over 3. So finally, you get 2 pi over 3 meters. Sometimes we know the angle and we know the arc length. So we need to use these two knowns to find the radius of the circle. So now let's look at the problem 98. Find the radius of the circle in which the given central angle alpha intercepts an arc of the given length s. So right now we know the angle, which is equal to 360 degrees, and arc length is equal to 8 meters. So right now we need to find the radius of this circle. So problem 98. Alpha 360 degrees, arc length 8 meters. So now we need to find the radius. So first, let's convert this degree measure into the reading measures. So alpha equals 360 degrees. Then we multiply this guy by pi over 180 degrees. Then we know this is equal to 2 pi. So now we use the arc length formula S, which is equal to alpha times r. And we need to solve this equation for r. So we just divide both sides by alpha so that we get r is equal to S over alpha. Right? So what is S? 8 meters. Right? So 8 meters. And then alpha is equal to 2 pi. So finally, you get 4 over pi meters.